model thinking, solving problems by programming knowledge system and programming strategies. I will explain programming knowledge system representation and derivation to solve problems by mathematical language. My goal by what to do, push students' programming skills, solving problems in a scientific way. The idea for my work is known to us all. Since 1990s, a large number of programming problems have been accumulated these years. And I think these problems can be used not only to train programming constants. If these problems are used in education, students' programming skills solving problems can be improved greatly. First, the teaching material. I published my teaching materials for curricular programming contests, strategy solving problem, and primary programming practice, as you have seen. In mainland China, simplified Chinese version are published. And in Taiwan, traditional Chinese version are published. And in America, by CRC Press, published the English version. This is the structural practice. As you can see, simplified Chinese version, traditional Chinese version, and English version. Now contains simplified Chinese, traditional Chinese, and English version. Now the latest version is the second version. Programming strategies. I published a simplified Chinese version and the traditional Chinese version. And now I also improved it. Strategies are published in and the primary programming practice, simplified and the traditional Chinese version. I think if we intend to evaluate a person's professional ability, we should notice two aspects for the problem. Second, his model thinking. That is, when he faces a non-standard problem, what strategy he should take. And in programming, I think programming knowledge system can be summarized as a famous formula. Algorithms plus data structures equal to program. Therefore, as you can see, and there are many non-standard problems we should solve by advanced data structures and optimized algorithm. For this part, and the basic units for the book series is experiments. First, I show the knowledge problems. I will give the analysis, solutions with detailed annotation, and the sources, and the ideas for my work's second part. Model is case teaching, and I use the online judge system and the virtual contest as the fundamental information technologies. And my guiding ideology for explain case teaching for students, case learning is our teaching model. Experiments, because as I have said, in the book series, experiments based on programming concept problems are basic units. In my concurrence, first, I introduce the knowledge background. Then, I let the students read the problem and put the students into the case of problem description. When they read the problem, they should consider how to solve it and propose the algorithms solve the problem. And then I gave the analysis. Students compared what they think with my analysis. And finally, students program and debug to pass all test cases with the time and with thinking. Second, stimulates students' desire for knowledge, and third, depends their understanding knowledge. Use this HTTPS vjudge.net contest. This is my course for international summer school in Shanghai Jiao Tong University. It's homework and examination. And I can say that my guiding ideology is programming is a technology. That is, first, I require students practice, and practice. Second, knowledge system solving problems by programming step by step. And second, in my book, for each program content problem, I provide analysis and the solution with detailed annotation, and the students can set up their knowledge system for solving problem by programming step efficiently and quickly. Third, practice examination is mock program contests. Let students solve problems. My third part, and the third part for my work is teaching system code solution. Miguel established in July 2017. Now near 400 universities from mainland China, Taiwan, Hong Kong, and last year also host a program training camp in Bangladesh and Malaysia. The program training legal first, the work first offer online optimal course for programming technology. Second, organize programming training campus in summer vacation and in winter vacation. And third, we also organize some practice contests, and finally hold all kinds of our programming training camp in Malaysia, in Bangladesh, in mainland China, in Hong Kong, Polio, Hong Kong. We host online program training camp. Participate in the program training camp from mainland China, Taiwan, Hong Kong, Macau, and Malaysia, and some Chinese students in Australia. And the teaching system closed solution, the work pattern is now we summarize as 1 plus M plus N participate in it, and N students pursue their programming skill. The innovations for my work is first, programming education is combined professionals in the age of AI. When I introduced background, I also said that because of the rapid development of AI, computational thinking and mathematical thinking for solving problems by programming, the training is, and the efficacy of my work is my work have been shared by many universities and widely recognized by teachers and students, and polish students' program skills, solving problems efficiently. And finally, I should say that now my work is supported by our university. That is, if I go to other countries to host a program training camp, the flights can be paid by Fudan University. Okay. This is my report. Thank you very much. And have you any questions?
Yeah, let's give a round of applause. And with that, any questions, anyone? Yeah?
How can the online judge system identify students who uses ChatGPT to cheat or to cheat for the homework? Yeah.
I select the online, your problem is about online judge system. I select this online judge system, virtual.net context, and through it we can select programs from different online judge system as programming context. As more program context. For example, okay. If convenient, I select. Okay. If convenient, we can. After that, I can show you how to select programs from a different online judge system as mock program contest. Okay.
Okay, next question. Anyone? Oh.
Yeah, so it's quite obvious, like China has a lot of knowledge in competitive programming, but is there any way for like people who don't speak Chinese to take part of that knowledge?
Oh, okay. Now I also host. As you can see. Now I also host. Let me see. Let you see. Now I also host program train camp in other countries in English, and I have said, now I work is supported by our university. Cities, flights can be paid by our university, and the host university only pay my local accommodation and the local transportation, and for my train camp, normally 1 to 2 weeks. In each work day, in the morning, I give lectures, and then in the afternoon, I host the mock proving contest, and I instruct students. Normally in summer vacation or in winter vacation.
Great. Next question. Okay, let's give a round of applause again for Yonghui. Yeah. Thomas, would you like to?
All right, and we are ready for our second speaker. So Miguel, do we have you here? Pleasure to have you, and we are looking forward to some influential work that you have for our future.
Okay. Thank you, Thomas and Chris, and thank you all for coming. Today I'm going to talk about a project that is emerging in ICPC that was suggested to myself and to Frederick Nimela here also a few months ago by Bill Poucher about the need of keeping an historical archive of all the problems and all the documents that are generated on every year and on the finals and also on the regional contests. And I have some, well, a bit of outline there. As many of you may already know, there was a ICPC Live archive that was live until a few years ago that included all the problems from the finals in the since the year 2000. Actually, it was until 2018, along with the problems of most of the regionals from that same period. It was a live archive in the sense that it was an online judge that used all those problems. For different reasons that are not important now, that live archive ended its existence something like 4 or 5 years ago. And since then, there has not been a standard procedure to keep and to preserve all the knowledge that we produce here at the ICPC. So, once we realized this and started to think how to restart that activity, we thought that it would be important to rethink it into more an archive and not necessarily live archive, because it doesn't make nowadays much sense to be able to solve problems from 20 or 30 years ago, as problems have changed a lot and technologies has changed a lot. So what we thought was about developing a new concept, and in the words of great Bill Poucher, it was we want to have the national library of programming contest problems. So we need to extend the concepts, the ideas, and to obviously make it better than it was before. And that's the motivation of this archive. There, yeah. So the end goal is to have a new technology that is seamless, integrated into the workflow of the ICPC World Finals on a first stage and on all the regions on a future stage, that it's actually self-updated in the terms that it must be a new item in that workflow to upload the problems there, or which is easy in the finals because it's a more controlled environment for us, but can be challenging in some of the regions. But that's the goal, the idea. I have to say, as part of the introduction, that this is a pretty recent project, which means that at this point we have more questions than answers. So I'm just presenting here the idea, the concept, but development has not actually started in its main part. No, the idea is to integrate all the future problem data, all the data that is generated every year, with all the historical archive that we have as files that can be in a structured language, or can be in PDF, in Microsoft Word, or even just as scanned documents. Which means that we have to standardize the way we present all that data to the users to make it available. For that, we are going to use the problem format that has been developed by the CATIS team, and that I think that in the next talk, in a few minutes, we will have more information about that format. It's important that our archive is more focused on research than on solving problems. There are many online judges all around, and it doesn't make much sense to have a new online judge, but to preserve the data, which is the main goal, and must be our focus. And as I said, the idea is that every contest that happens within the frame of the ICPC is mostly automatically uploaded and available to users all around the world. Of course, probably the first item is always set in any new project, a clean, intuitive user interface that is good for users. wouldn't make much sense to say that we want to have an ugly and useless interface. So yeah. But the second item is more important because we want to make the problems searchable by not only by the final they belong to, but by algorithm, by many tags, by difficulty, and we have to develop the ways to rate this kind of tags. But some of them are very easy, but tags like difficulty, it's actually not that clear how to make happen. Other kind of tags, probably here we will be helped by AI for quickly tagging, at least on a first filter, and then allowing users to add tags, custom tags, depending on what the problem is or how the problem is. There will be each problem will be like special content by itself, as we will have very detailed information about each problem where users can contribute, comment, or add whatever they need is important. So each problem can be discussed on its own. In the features that are new and will be innovative in relation of what we have before, it's the third time I mentioned this, but it's actually probably the most important feature, is real-time updates after each ICPC contest. We've been trying to do this in different ways for many years now to succeed. And we have to give it another try, a new try, with regional contest directors to make them know how important it is to preserve all of that, and how sad is that the problems from a regional contest are lost in 2, 3, 4 years after the contest has happened because the web pages are down, because no one actually saved the version of the contest, and how much we have lost already, and how we have to make the effort to stop losing that kind of documents, of content. It's very important to keep it. Even only for historical reasons is important, but it also can be used for research, for learning, of course. We want that the archive is useful for many different profiles of users. Might be students, might be researchers, might be coaches. So we have to allow them to customize the experience to a great extent. And that's the idea, as I said. We now have to think and to develop how that will become a reality. Also, obviously, it will be the home of a community to discuss the problems itself. I don't think that ICPC, well, I'm sure that ICPC is not offering that now, and we think it's important to get feedback more than the feedback that we get on the contents themselves about the problems and not other activities. This leads to the first task, or one of the biggest tasks, and is to standardize the problems. As I said before, we have, especially in the older contests, we have problems that are scanned in PDF, in LaTeX, in Word, in HTML, and any format. That obviously is pretty much useless for working on indexing and tagging the information. So the first, or better said, the second task after having an inventory of all the problems that we already have, is to standardize its format to the CATIS problem format, which is a structured format language in XML. So it makes much easier to store the problems, to share the problems or between different entities. Obviously, we have to, some things here are actually pretty much normal. We have to ensure that the system is scalable and that we can start with the world final problems, which wouldn't be that many problems, but after that we want to open it to all the regions, which would be thousands of regions, of contests. And obviously it's important to keep the property, the intellectual property, the copyright of all the content. And this is something that it's not being done in many areas, not only in this one, but in many areas. Many times we have problems, we find problems, and we don't know who is the author, where the problem came from, who owns its rights for educational purposes or commercial purposes. So we have to work on that and explore that and try to attribute each piece of data to its author, or at least to where it came from. So a big focus will be there. And today, with the emerging of many IA companies that are using these kinds of data to train their models, it's even more important to make sure and to have a clear idea of who is the owner of all of this. Now the idea is that the tool can be useful for education and for preparation or training for competition, as long as I said before, research or just for the sake of archiving the data. So it's important that I think it's very, very important that we preserve that, and that once each final, each regional passes, there's still something that remains, in this case, not only the rankings, but also the materials, the problems themselves. It's important that we are able of bridging the gap between the old problem formats, and here I'm not talking about the physical format in which the problems are created or stored, but the conceptual formats of the problems, as problems themselves have evolved a lot in the last years. And when one takes a look at problems from 15 years ago, you realize that that would not be usable in modern finals, for example. Many things have changed. So we have to make that a bit more, find the common points on those contents. And so also it has to be an open archive, in the sense that we want the community to give us feedback, to provide their own vision, their own experience, to enrich each problem, each piece of data. In the future, the idea behind that is I said our idea is to start with the World Finals, which is easier for us to use that as a basis to develop the platform. But the idea is to include, to the maximum extent that we can, the regional contests, the regions. Even at some point, we should think about including local contests, as long as they are related to ICPC. But obviously, that's for the future, not today. We also want to make it accessible to an API, so users can extract information from the archive without the need of going through the web interface, and they can automate things, or they can upload things, or maybe at some point the judging systems for contests themselves can upload the problems automatically through an API. We don't know at the level of functionality that we can achieve that, but it's important that it's can be done through an API. And also we have to explore, and this is just explore, it's a concept we are thinking of, explore the ways to provide access to third parties, which are probably commercial parties, so they can use the contents, the problems in their own online judges. Obviously, in the educational world and for educational purposes, there's no much, not a big discussion. But everyone should have access, but we can also explore ways of licensing the contents to commercial parties. So that's another point that we have to explore, and where feedback will be important from the community. Once the platform starts working, it will be important that we get lots of feedback about that. And that's pretty much it, because as I said, we have more questions than answers at this point. This is just a concept that started a few months ago, I think it was in May, and we have more been talking about it than actually developing it. And developing should start pretty soon, but as of now, it's just the idea. So I will be happy to answer your questions, because we actually, it probably will be more interesting in if I have been able of raising any questions around.
Great. So let's first of all give a round of applause for Miguel for the presentation. Yeah. I learned quite a lot. So, and then with that, let's open up for a question. Oh, Jonathan.
Yeah, I'm here. Thank you for the presentation. So yeah, I have got two questions. First is, yeah, I understand you talk about like development is not yet, but you talk about clean and intuitive UI. We always like that. I'm wondering whether there are mocks yet that you can show us, because we would like to see that. Second is there an initiative as well to archive results? Because like even like Word Finals results from like even like 5 years ago, it's not easy to get the full standings with like these teams solve which task at which time. And I think we the website, the ICPC website right now only archives like just the number of AC and time. So I'm wondering whether there is also initiative to archive that. Thank you.
Well, actually, as results are part of the legacy, then it should also have its place to be in an archive. So yes, as we are archiving problems as sets from finals or for whatever, results probably will find their way there. But obviously, you have the limits that you can have a capture of the results, but not necessarily that means that we will have the resources to find everyone that is behind that results, more than the university, maybe the contestant names. But as far as it's part of what is created in the context of the finals, yes, the results are interesting to have.
Yeah, and I'd like to actually add one more thing, that the ICPC Foundation has an internship program where you can utilize some of the interns to help you with your work.
Yeah,
so
of course.
we can discuss that line.
We have to thank Christian for providing us with the future resources to work on many of the most arduous tasks,
Exactly.
such as converting problem formats.
Right. You know, I don't want you to do all the work. We might as well offload some of the work, right?
Okay.
So, right.
I think
all right.
there was a
next question. Yep.
There.
Yeah, I got two questions. The first one is related to the first session we had in CLI, where we had a presentation for solve.ac that also qualified a lot of these problems and had a lot of trouble guessing difficulties of the problem and how to properly qualify it. How are you going to reinvent the wheel, or gonna talk with the presenter to maybe reuse some of his findings? And the second one is more in question about the commercial use you have in mind. For my region, all problem sets are licensed for non-commercial use. Will that be protected? And also, especially in the case also for training in artificial intelligence sets.
Regarding your first question, about difficulty, we will reuse whatever we can. We have to determine how. Probably there are many problems that are quite easy to categorize in difficulty. But obviously, it's always a problem, or you can be empiric and wait until you start getting results to determine which is harder because it's less solved. But it's not. But it's not an easy one. Tagging is easier. Difficulty is more difficult. Regarding commercial use, one of the points is that obviously we will go to the source of the problems whenever we can, whenever that's available, to ask what is your if you have an actual license. But probably that it's more related to regions, as obviously the problems in the World Finals belong to ICPC, I suppose. So that will be easier, but the problems with the finals we will have to see. But obviously our aim is to always protect we are focused on copyright, on property. So obviously we will look at the root, at the source of the data before we license it to anyone.
Great. And I guess if you need connection for the people from the first presenter, I can give you the contact information so they can actually interface offline. Yeah.
Okay.
All right. Any other questions? Oh, great.
Hi, I remember the previous archive, so that's something we certainly contributed to in the past. A couple things. One, certainly among some of the problem materials, at least those in the intermediate past, I'll say 10, 15 years ago, I think there is metadata that'll talk about the licensing or the intended licensing for it regarding the last topic. You talked about something else, though, and that is, besides just the problem texts themselves and any data or whatever you can capture, is there any way to capture what I'll call related or tangential information? And I say this because I've got problems from Southern California, say going back probably 25, 30, maybe even more years. And some of them maybe even have interesting things that happened during the contest that used it, anecdotes even. And I think it would be interesting to try and capture that kind of related data for, if nothing else, for historical interest, besides the actual contents of the problems themselves, and if need be, if it's still available or could be rebuilt, what would be needed to put it in an online judge. Yeah, a lot of the problems would be dated, but some of them would still be relevant today.
Yes, I said before, the idea is to treat each problem like it was a book in a library, and then there's obviously that there will be the place so users can contribute their comments, free comments, to the problems in the archive. So that will be the way of rebuilding that, probably, as long as people engages and uses the feature. Probably whenever we have available even all the judging in the problem, if that's available, we will include that also with all the timings, and so you can at some point even compete against those finals or those finalists. But the idea is to collect as much information as possible from starting with the statements themselves, which is the easier thing, but then adding as much additional data as we can find, having in mind that we are talking about several thousand problems here, and probably we will need a lot of help from the people that was actually there to provide us with that information. But yeah.
Actually, I might have one question. It's not a tough one. I would say collecting 90% of the data that is out there is very easy. But last 10%, or let's say just missing data, could be quite cumbersome. Do you have a plan for how we can actually collect, let's say, exhaustive, all the problems?
Detective work, trying to contact the people that was there at that point to just check if they still have even a hard copy available of that to scan it and send it to us. But yeah, it's really difficult. Again.
Oh, yeah.
Mark again.
Yeah, one quick follow-up. There have been several initiatives in the past to try and capture, I'll call it metadata or something around the different contests in the past and kind of a more comprehensive ICPC history, not just necessarily the problems in judging. Is that moving forward also, and is there any interest or any efforts to kind of integrate the two?
We would like to do that, and this time this is not called Live Archive or Problem Archive, it's ICPC Archive, but we will start with the problems. But the idea would be that ICPC archives everything that we can, but we have to start from some point, and this would be the problems at this point. But yeah, I think, I mean, at least in my mind, we don't have even discussed it, but in my mind, it's always been that idea that we can collect more than problems.
Any more questions? I think it's a very popular topic-wise. We are getting a lot of questions, which is great. Any more? Going once, twice? Okay, so now let's give a final round of applause for Miguel. Yeah?
To Frederick also, who is so involved as so.
And Frederick too.
Frederick too.
Frederick is awesome.
Thank you.
Thank you. All right, the next person in line is Joshua. If you can, yeah.
Okay, hello everyone. So my name is Joshua Andersson, and I'm from Chalmers University of Technology from Sweden. And I'm going to talk about an update to the problem format. So this is actually so Miguel just in his nice talk talked about yeah, we need to put them in a standardized format. So this is actually the format that we're using for ICPC archive is getting an update. And I'm basically going to talk about what is being changed. So first off, what actually is this format? So I guess as the name kind of implies, it's a format for creating problems and then sharing them. And this is used pretty widely, both in contests like the ICPC World Finals, lots of regionals, but also in education, multiple universities use it for their courses. And one pretty nice feature of it is that there is a pretty strong focus on correctness. So a lot of the things that can be validated are, and as a testament to that, there have been no major data errors in the ICPC World Finals since it was started to be used. So a bit of an outline. So this format is actually pretty old, and it has been changed slowly over the past 15 years, maybe more, I'm not sure. But yeah, but now in about a year ago, they decided that they actually want to systematically make a pretty big change, big enough to warrant a new version. So there have been 3 workshops, and now in the last one, we have kind of decided that, okay, now we have basically converged enough that we want to announce this. So multiple people have already started implementing this new format. And so the focus today is going to be which parts should you actually care about in the changes? So unfortunately, I don't have time to actually explain the whole format. So if you don't know it from before, then sorry, this may be a little boring for you. Okay, first off, so I think probably maybe the biggest feature is a new problem type called multipass. So what this allows you to do is basically that for one test case, you can rerun the user submission multiple times. So the way it will work is kind of that first, the user submission is run as normal. It gets some input, it does some computation, and then produces output. Then this output is fed into a so-called output validator. In some circles, this is also known as a checker. So what the output validator will do is first check that you have actually solved the problem that you were supposed to solve. And then at the end, it can either choose to say, what it normally would do is simply say, okay, the submission should get this many points on this test case. But what it can do now is also say that, okay, I want to rerun it. And what it does then is that creates a new input file for the submission. And then the submission is restarted and run with a new input file. And then that creates a new output file. And this is looped until the output validator says, okay, I'm done, this should be the score. And then of course, the output validator can keep like metadata between the runs, like, I don't know, kind of whatever you want, arbitrary data basically, that only the judge can see. So one pretty nice application of this is the so-called, I like to call it communication problems, where it's like person A has a message and what to send to person B, but then somehow the communication channel is not perfect, then you have to work around it somehow. So this is already common in IY, and you could actually do this in Kattis before, but not really, because you could kind of cheat it. But now what will happen is between every time the submission is restarted, like the whole sandbox is restarted. So it will be like a blank slate every time. So to be clear, I'm going to give you like a concrete example. So say that we have like two people, we have Bob and Alice, and Bob wants to send a message to Alice. And he can do this by sending like arbitrary many bits, I mean some reasonable limit. And then along the way, one of the bits may be flipped. So like he sends it to Alice, and then she has to like unflip the bit and find the original message. So the way you do this is basically like, first the submission would run, and the input says that, okay, you are Bob. Then Bob produces some output, and then that the output validator takes the output of Bob and maybe flips one bit and then creates a new input, and it's run again. And now the input to the submission says that you're Alice, and this is like Bob's output, and you have to unflip the bit. So this is like, so this will be like 2 rounds, but in general you can run it even more times. And I really hope that you'll create like creative problems using many rounds. I really want to see like what can be done with this format. So as I said before, if you really need this and you really want to do it right now, it is technically possible in the format. And if you download the slides later, there's a link to GitHub. But it's kind of tedious, not nice, and it's kind of easy to cheat. Okay, next problem type, submit answer. This is also known as output only in IOI circles. So what you would usually do is that you submit like a program that solves the problem, right? But here it's rather that you submit for each test case, what is the answer to it. So then usually where you would want this in, it's like, oh, all test cases are public, and then implicitly the time limit is the contest time. So applications might be like heuristic problems, those are pretty common. And another one might be you can even hold an AI competition, like you're given some training data and then some data to make predictions on, and then you upload like your predictions and you get a score based on how accurate you are. So you could even hold like Kaggle-style competitions on Kattis if you want. So I mean, this is already possible, but now it's, when it's a first-class citizen, then the judges can make it a little nicer, the UI and everything. Then this is a feature that is completely new and pretty interesting in my opinion. So as I said before, the output validators would check like, oh, is the output correct? But static validators run on the source code. It checks like, is your source code correct? So one example could be like education. Let's say you have a problem there where the assignment is solve this problem using a while loop. And they can actually check that they have used a while loop in the submission. And there's a pretty interesting one. So earlier this year I hosted an April Fool's contest where the goal is just like, oh, solve some normal competitive programming problem. But we didn't tell them this, but the score that you got was the percentage of A's in the source code. And then you have like that coupled with like a limit on the number of characters in the submission meant that actually the hard part was solving the problem with few characters and then just like putting a comment with lots of A's in it. So it became kind of code golf. So now that is possible in Kattis, if you want to do that. But I would say in general, like use this with caution. You don't want to create problems like, yeah, solve this without using a segment tree, because then you have to check, are they using a segment tree? And you don't really want to do that. And in general, like parsing source code is non-trivial, especially if there are multiple languages. So I would say that this is mostly useful in education. Just keeping my time. So another thing is statement. So you used to only be able to do statements in LaTeX, but now you can also do in Markdown. But actually, like, what is Markdown really? There isn't really a standard for it. There's like one of the most common ones is called common mark, and that's what we're using as a base. But that's not really powerful enough to do everything you actually want in a problem statement. So I have common mark plus footnotes plus tables, and the format is basically the most common unofficial one. It's not specified, but basically what Pandoc does, and most reasonable implementations do. And of course, we have math in the standard, like put $2, put LaTeX style math, and it will just work. We unfortunately don't support arbitrary HTML, even if that's technically a valid markdown. We don't want to risk like having arbitrary JavaScript run for every person who opens a problem. Kinda unnice in my opinion. And you can also now supply write-ups to tasks in either PDF, LaTeX, or Markdown. And it's up to the judge system how these are displayed. Maybe it's like a contest system, they're just shown automatically after contest ends. Maybe they're always shown, maybe after you solve it. It's up to the implementer or the format. But this exists now. Okay, so now for test data. There have been some changes to like exactly the structure of it, but those don't really matter that much in practice. So there are a couple new features though for test cases. So you can include visualizations of the test case, which you can choose to show to contestants and or judges. You can include like documentation saying like, oh, this test case is trying to kill this approach. So you can document to other judges in a standardized way. You could also have hints which are like shown to like, oh, if they fail on this test case, they're given this hint, which is nice in education. And you can also, if you fail a test case, or just given the whole test case, which is once again super useful in education or beginner contests, because like they don't know where they're getting a wrong answer and they suck at debugging. There are also more input formats. So it used to only be like standard input-output, but now you can like read from files or read from command line arguments. And in general, this is not recommended because everyone already knows how to read standard input-output. But once again, useful in education, probably. And also, you have more control over samples. So you could have like, do you need to actually pass samples to pass the problem? Sometimes it's harder to pass samples than the actual problem. And then you could have like, maybe you want the samples, like judge solution to be, I don't know, 30 digits of precision, but you only want to show 5 because that's more reasonable. Then you can do that you have like one display sample and one like actually used for judging. Then for judge solutions, this is actually a very nice feature. So you can now basically specify like for each submission, what verdicts should they be able to get on every subtask. So say you have one submission, you can say like, oh, on subtask 1 and 3, it should always get accepted. 2 and 4, it should always get wrong answer. And on 5, maybe it gets wrong answer, maybe time limit. It's kind of unclear which one it will get. So you can say it can get any of those. So this format basically allows you to specify very like detailed exactly what you want, but you can also be general, just say like, yeah, this submission should always get wrong answer on everything or always accepted. So it may be a bit verbose for like some ICPC contests, and maybe not suitable there. But if you have like a problem with lots of subtasks, lots of judge submissions, and lots of judges, then it can be very nice to like actually document what every submission should get in a standardized way. And there's also a new folder called brute force, and here you just put like submissions that are like slow, maybe dumb, but are always correct. And you can use this to like, the intent is basically to double check that the judge solution is correct. Then for output validators, these must now only be written in C++ or Python. And this is because there have only been 4 instances ever, I think, of not Python or C++. Unfortunately, one of those is from Sweden, and it's 1,000 lines of Java code, so unfortunate for that problem, I guess. But another nice feature is that now you can say that, it used to be that the output validator says, oh, this submission should get this many points on this test case. But now you can do instead that, oh, you should get 50% of the points on the test case, which allows you to, like, for example, let's say you have the problem subset sum, like, is there a subset with sum exactly x? And if you answer yes or no correctly, then you get 50% of the points. And if you actually find such a subset, you get 100% of the points. And this is something pretty common in IOI, and of course it was possible before, but now it's a lot less tedious. So a new feature, output visualizers. So these are run on every single output, and it should produce a JPEG, PNG, or SVG, which you can choose to either show to contestants and or the judges. And so this is kind of pretty nice, I think, but it's non-trivial to actually output valid PNGs or JPEGs or SVGs. So I think what's going to happen in practice is that someone smart is going to write a like a very concise header file which outputs minimalistic valid PNGs, and that's going to be distributed among judges as like folklore. I think that's probably what's going to happen. Then graders, or rather lack of graders, we have completely removed custom graders. This is because were like basically all custom graders were re-implementations of the default graders, sometimes even with bugs. So what you can do now is simply give like command line options to the default grader. It's fully documented, it's available on GitHub, and it basically allows you to do everything you would want to do. And another thing is that all problems, the objective is now always to maximize the score. Sometimes before you could do like either maximize or minimize, but there were only like 2 instances of minimize, so we removed it. And if you really miss old like custom graders, then you can actually do multipass to do everything that old graders could. But things become a little weird and like not as nice as they should be when you do that. So I would discourage you from doing it. But if you really, really need it, then it's still possible. Then subtasks, so even more for IOI style contests. So it's very common to have something like, oh, for this subtask we have n is less than 100, and for the next one we have n is less than 1,000. Then logically, we need to pass every test case in n is less than 100 to even like attempt n is less than 1,000. So people already kind of do this by like symlinking over all the test cases, but now the judge actually knows about this information, so maybe they could show like, yeah, we didn't even run the n is less than 1,000 subtask because you failed something in less than 100. And it's like less files and less tedious. So it could be done before, but now it's nicer. And also, if you don't specify group score for like this subtask you get this many points, you should do that, but if you don't, then the judge will automatically divide like 100 points equally among all the subtasks. Then problem not YAML, the metadata. So this one is pretty nice that there are more ways to give credit now. So it used to only be like author, but a lot of people had their own interpretation of what the author actually meant. But now there are like 6 categories. I don't remember the exact names, but it's basically like the author, the one who came up with the problem, the people who implemented it, the people who tested it, the people who translated it, and then a general like catch-all acknowledgements, which doesn't fit in any of them, and then also like archiver basically, like the person who recreated the problem package or stuff like that. And each one of these is of course a comma-separated list of author names, and you can also include emails. So this is pretty nice where people actually get credit for the work that was done. Now, then you must also now supply a UUID for every problem. I mean, I thought that this was a bit weird at first too, but it can actually be non-trivial to know like there can be multiple versions of a problem across multiple repositories, which are like slightly different, and you don't know like, oh, is this like, should this new version like replace the old one, or should there exist 2 versions of the problem because they are so different? Now you can actually like communicate that more clearly. Then you can also define problem level constants. This is another very good one. So you can say like maxn is equal to 10,000. And if you write 2 curly braces and maxn in any of the files in the package, it will automatically be replaced then by 10,000. So you can have it like submissions, like, oh, the array should be maxn size, or maybe you could do it in the statement, or the input validator, or generators if you have that. So now you don't risk like having different, like out of sync constraints in different parts of the package. And finally, the default time multiplier has been changed to 2. It used to be 5. So you like do with that as you will. Basically, you may want to like include slower judge solutions, or just change it to 5. And then in general, so generators are not part of the package, but if you do, if you're using like IOI style problems with lots of subtasks, then it can be kind of tedious if you don't use generators. I would strongly advise using them. So there are 2 main ones in use that I'm aware of. Please tell me if there are more. But the ones I know of are BAPC tools, which is like a re-implementation of problem tools, which has a lot of features. And then there's a simple one called test data tools, which is basically a simple command line script that does basically what you want to create test data. And there is also a folder called data/generators, so please place your generators there so we can archive them. But that folder doesn't actually do anything. It's just like, yeah, please place them here. And I think that was like the biggest features, basically. So these are the people who helped create the new format. So please, a big round of applause for these people. And here we also have a picture of the people from the last workshop in Stockholm. So if you see any of these people, please go ahead and talk to them. They are very nice people, and they know a lot about the format. So yeah, that was that. Do we have any questions?
Hello. So let's give a round of applause for Joshua, first of all. I guess to start off, can I sign up for this? It sounds very exciting.
Yeah, you go ahead.
Cool. All right. Any more questions? Oh.
So, will the old version be deprecated?
No, the old version will still be. We don't have any plans to deprecate the old version, as far as I know.
Oh, okay. Jonathan.
Thank you. Can you go back to the slides where it says max n for statements and input validators?
Sorry?
Yeah, the next slide, I think. The one that says max n for, yeah, this one. Say max n in statement and input validator.
Yeah.
So there is similar effort in the framework that we use for IOI, which is called task preparation system, made by Iranians, I believe.
Yeah.
But we had concern on that because like sometimes we want to display numbers differently in task statement. Like if it's 10,000, then it's just 10,000. But if it's 10 to the power of 9, we want sometimes to just say 10 to the power of 9. And if it's like 2 to the power of 32, we don't want to say 2147 something something 1 to the power of 32. So that's the first question. Like, have you considered of like how to handle that? Because like sometimes we don't want to render number as it is in the statement. And the second thing about input validator is that also sometimes I want my input validator to be a standalone code that I can just submit to DOM judge. Like let's say I want to make sure that I upload all the test data correctly, even though I know I made local validations, but sometimes we upload wrong things. So I want my input validation to be a standalone code that can run using the input. And I want to make sure like, let's say I have an input validator, like it should say wrong answer instead of runtime error, right? Like usually like input validator, I don't know how Kata's problem package format of input validator is, but I usually like my input validator crashes if the input does not confirm. So like, and then I want to be able to submit that to DOM judge so that I want to make sure it says wrong answer instead of runtime error, right? But if we do something like this, then I believe like your input validator will, your max n will take from the problem.yml, which makes it not standalone, right? So if I understand this correctly. So yeah, those are my two questions.
Okay.
About statement and the input validator.
Yeah. So the first is a very valid concern. We have actually not debated this, and it's kind of a hard problem in general because it's kind of, I think, up to the person if you want, like, I think like 1,000 should be 1,000, 10 to the 5 should be 10 to the 5. But people, like even for something as 10,000, people don't really agree. So I'm not sure, we haven't really discussed this, but it may be something worth taking up. So that's a very valid concern. And for the second problem, so if I understand you correctly, so you're saying basically that you want it to be, I'm not sure I actually understood fully your second question. Could you?
So in the past, before this,
Yeah.
Input validator can be a Python file, right? A standalone Python file that you can run with the input,
Yeah.
and then it should maybe crash if the input does not conform to the task constraints,
Yeah.
and it should maybe exit gracefully with no output if it doesn't, right?
Sure.
And if you have that standalone validator, you can submit to DOM judge once you uploaded the, or like let's say my contest uses DOM judge. So once I uploaded the test data, I usually submit that validator as a solution to make sure that it gets no wrong answer instead of runtime error. That means I uploaded all the test data correctly. Yeah, and
Okay.
if we use something like this, then my validator, my Python code validator won't be a standalone file that I can just submit anymore, right?
Yeah.
Yeah.
Okay. Yeah, Fredrik seems to want to answer that. Yeah, I had never actually heard of that use case before, but that seems pretty smart.
So the constant stuff is a simple pre-processing step. And you know, if you want a program that is useful without the pre-processing step, simple, don't use constants, right? That's really the answer. And again, we actually did discuss the first question too earlier, very early in the process. To solve the formatting issue in LaTeX versus Markdown versus code is really, really hard. And where we kind of landed was use the constants for plain values. And if you want fancy formatting in LaTeX, what you should be doing is write a LaTeX function that takes the value and formats it in the way you want, so that you have separated the representation of the value and the presentation. And now, do I think people will actually do that? No. I think people are like me, they are lazy. But that's how you, quote unquote, should do that. Is that the answer you were looking for from Joshua? Yeah, okay.
Okay. Any more questions?
Is the source validator also useful for preventing hard coding, perhaps?
I suppose you could do that, yes. And but you probably shouldn't need that. I mean, one of the primary usages which I could envision would be like not allowing them to save stuff in multipass problems. But now we actually have multipass. But yes, you could probably do that, but I would be very careful when doing it. Yes.
So I guess for the interest of time, I guess we can move on to the next talk. But yeah.
One more question.
Oh, one more? Okay, sure. Oh, Etienne.
Yeah, so what I recommend for the constants is to have just two, one that's maxn and one that's maxn_LaTeX, and have them both in problem.yaml. Now sure, this is not as ideal as having just a single constant, but at least this way they're defined in the same place in the same file, and it's less likely they'll become out of sync.
Sorry?
Great, awesome. So let's give a round of applause for Joshua. And
is this one working? Yes,
yeah,
great.
So that's working. Great, thank you. Great, thank you. Yep. And the next person in line is Matt from JetBrains. So let's give him a round of applause, right?
Thank you. I probably should have stood a bit closer to the stage. Sorry about that. Yeah, hi folks. I'm Matt from JetBrains. I'm a developer advocate, and today I want to talk about teaching Kotlin. Using Kotlin as a language in your classrooms and teaching that to students, and how and why you might like to do that. So the tagline we're using for Kotlin at the moment is concise, multi-platform, and fun, which doesn't tell you a huge amount about the language itself. But one of the nice things is the fun bit at the end. It's a bit of a joke, a bit of a pun on the fun keyword that we've got in the language. But also we get a lot of feedback that actually people do really enjoy Kotlin. They enjoy writing Kotlin and working in it, which is a nice thing. So the Kotlin language itself, we created it back in 2011. We built it for ourselves initially. We wanted a programming language that was more modern, that we could use more modern features with, and that would make us more productive. And we also needed it to be 100% compatible with Java and with the JVM, because we've got a lot of code already in Java. We've got all of our IDEs built on Java, the team tools built on Java, so we needed it to be 100% interoperable with existing code. We didn't want to have to throw things away and start again. And so we built Kotlin, we built it on the JVM, and that's where we are now. It's also multi-platform, targets other platforms, including Android, iOS, JavaScript, WebAssembly, and native code. And before I move on, I meant to point out it's open source as well, and it's governed by the independent Kotlin Foundation. So if there are any incompatible changes, it has to go through the foundation first. Talking about multi-platform, the key thing there really is that this is part of the language. It's not just sort of the ability to target different backends, but you can share code between the different platforms. So you can have some common code which expects the platform to provide some information, and then the platform version can actually provide it too. You can target the server, you can target Android, of course. Kotlin is very popular on Android, and it can also target iOS, desktop, and web. So we're very pleased to say that nearly 400 universities teach Kotlin. It's all around the world. It's going very well, very popular. We'd obviously like to increase that number and help out with other people teaching it. We've got nearly half of the top 100 universities in the 2024 Times Higher Education rankings, and using that. And of course, Kotlin is being used in the business world as well. So you can be setting your students up for success for when they graduate. One of the things we offer to help you teaching Kotlin itself is a programming course. We give you an entire course which is available to use. We've got a slide deck, speaker notes, exercises, assignments, and so on. It covers all the features you want: functional programming, object-oriented programming, exceptions, generics, lambdas, and also concurrency and coroutines. Kotlin's got a great story for structured concurrency. And the link for that is just down the bottom here, and all of the links are going to be available from kotlinlang.org as well. And that's all free to use, free to modify. You can adapt it how you want, you can teach whatever you want, you can do what you want with it, basically. So, teaching Kotlin, how would you do that? How do you go about that? Why would you go about it? And what does it mean? So some of the characteristics of Kotlin are that it's a general purpose programming language. You can use it for pretty much anything. You can use it for server-side code. You can use it for desktop applications. We're doing exactly that with our IDEs and our team tools. And you can use it for mobile and also for web tools as well. We're doing that for all of those features there. It's modern, safe, and multi-paradigm, which means that we can use it in an imperative manner, functional manner, object-oriented. It's safe in that it's got null safety baked into the type system, and it's obviously sort of based on more modern sort of foundations and technologies that we're using for programming language design recently. It has a big emphasis on conciseness and expressiveness. We want to try and remove the boilerplate from the language so that you don't have to worry too much about syntax, and you can actually concentrate more on solving the problems that you want, concentrate on the business logic. And so by trying to be as concise as we can also try and be very expressive so that you can read the code and you can understand the logic behind it without getting bogged down in syntax. And again, as I stated, it's 100% interoperable with Java, the JVM tooling like Gradle, Maven, and Ant, and also the JVM tooling and libraries such as Spring Boot, JUnit, Apache Commons, and so on. How does it help your students? How does it help using Kotlin as a teaching tool? An int, it's fine. And we can too, it's obvious. But it's still a statically typed programming language. It's not dynamically typed. We're just statically typing it. We'll infer the type for you. Looking at the for statement there, we don't have to worry about the crazy syntax of C for loops. We can just do something a little bit cleaner and have a range of items there. And we can do simple string interpolation as well. So we don't have to worry about fairly arcane syntax for formatting strings. And speaking of strings, we can also just intuitively do equals on there using the equality operator. So again, it's trying to make things a little bit simple so that we can sort of expand and grow things, grow the concepts a little easier. Now I mentioned common tasks should be easy to do. That's what we're aiming for. And Kotlin comes with a standard library which provides a lot of rich functionality there. So we don't want to have to start thinking about stream readers and streams and what have you there. So it's just, let's have a readlines function. We'll just have a readlines function which returns me back an array, a list of string values, which are the lines. We also want to minimize the typical sources of errors, and this is a good place to sort of introduce one of the key features of Kotlin, and that's its null safety. Null support. What is the word I'm trying to say? The nullability support. So the type system, it's all baked into the type system itself. So by default, any type you're using, if you've got a string variable, you know it's going to be a string value. It is not null. If you want a value which can be a string or null, so for example, the readline function here can return back an actual string or it can return back null, you have to mark it as such. So you've got string with a question mark after it. That is a nullable string, and the value can be string or it can be null. The compiler also keeps track of this throughout the code as well. So when you've got a check, such as here, if name doesn't equal null, inside that, we know the value is not null. The compiler knows that, and it can be used directly without having to do any further checks. Outside of the if statement, on the next line there, say we're trying to print the length of the string, we no longer know whether it's null or not. So we have to use the conditional operator there, the question mark dot operator, before we can access the property. We could also then fall back, if it's still null, we can use the question mark colon operator, the Elvis operator, to fall back and give us a value there. So null safety there is a very useful feature that is part of Kotlin. So moving on and having a look at some object-oriented programming. We've got simple objects for classes there. We try and be very concise when we're declaring a class. And so we have the idea of a primary constructor. So the class itself, the declaration includes the constructor. And on the top there, we've got these val keywords and the var keyword. These are declaring properties. So we don't have to have a separate constructor which assigns to fields and so on. We can actually declare those as part of the constructor itself. Val means it's an immutable value, and you can't change it. And var is a mutable value. Mutable value. It's a property. The compiler will generate getters for our immutable properties, and it'll generate getters and setters for our mutable var properties. And then we've just got a simple string function which returns back the sound that our car makes. Calling that object is nice and easy. We don't actually use the new keyword. We just effectively call the class as a function, and we return back a new instance of that function. And so you kind of join up the dots a little bit there of the constructor and creating the actual class itself. So I've mentioned that we actually want to, we're aiming for conciseness with Kotlin. We're aiming to keep the code concise and short and very expressive. But verbosity still has its place. It's useful to be able to see exactly what's going on with the code, and rather than relying on the compiler generating everything for you. And Kotlin can do this whole sort of range between the two. You can be a bit more verbose when you need to be explicit, or you can be more concise when you know what's going on. You actually want to be more expressive, for example. Type inference is a great example of that, where we don't have to specify the type at all times, but you can if you really want to be sure about it. And the same with data classes. So here's a good example here, the classic example of a data class, where on the left we can be as verbose as we want to show you all the code that the compiler would normally generate. It's got a constructor, it's got fields effectively, and then we're overriding toString, overriding equality, overriding hash code. Or we can just use a data class and very concisely declare that, because we know, as it's a language feature, that the compiler will generate that for us. We've got our primary constructor with our 3 values. We know that the compiler is going to generate getter, they're immutable getters for that. And we know, because it's a data class, that the compiler will generate overrides or equality for us. We've got less code there. It's a bit more expressive, and we have less chance of making mistakes, missing something out of our equality, making a mistake in our hash code, for example. And consuming objects from Java is very simple as well. You just use them. We just import them. We can declare types, declare properties of a Java type. We can also use a default value as well. So if you call this, this constructor without any parameters, we'll have a default value used, big integer .0, and you can just then also use static methods, and we're fine. It also works in the opposite direction. You can consume Kotlin objects from Java here, so you can just create a new instance of the Kotlin engine. We've got overloads of the constructor there, so you don't have to pass anything through, and you get a default value back. So it's worth pointing out there that all of this just works out of the box. You don't have to create any wrappers. Things just work in both directions. So let's have a quick look at using Kotlin for functional programming. So I said we can be sort of multi-paradigm. We can do imperative programming, we can do object-oriented, and we can do functional programming as well. We have functions as a first-class type, so we can have function references. The increment value there, for example, is a function reference. You can see it's got the brackets, it takes in one parameter there of an integer, and it returns an integer. We then set that to the value of a lambda expression. The lambda expression is defined by the curly braces, and that is a function with a parameter a, which is of type int, and you can see the implementation of that is a+1. We don't have to put the return value in there, that just happens automatically. And again, we can see type inferencing for that as well, so we can see decrement. We don't have to specify the type directly, the compiler can do that for us. Again, we can specify the lambda expression, and we can implement that. Those function references can then just be called as normal functions. You just pass values to it, and it works as you'd expect. And then because we've got function references, we can use higher order functions as well. We can pass function references around and call them. So in this example, we've got an apply twice function, which takes in a value, and it also takes in a function. That function, as we can see from the signature there, takes in an integer and returns an integer, and then you can very concisely call that function once with the value passed in, and then the return value of that is then passed into itself again. Applying that and using that, we can see in the main method there, in the main function, you can see apply twice, we are passing in the 10, and then we're passing in a new function, a lambda expression, which is just it times 10. This is another little bit of conciseness we can do here. If the function only takes one parameter, we don't need to specify it and add more boilerplate. We can just use the keyword it. So again, we can be a little bit more expressive, a little bit more concise. And in fact, we can do something a little bit nicer there as well. If the function, if the last argument to a function is a function reference, then we don't have to include that in the argument list. We can actually put it outside of the argument. So it's quite subtle there, but you can see it's part of the argument list here, but we can also put it outside of the arguments as well. This again allows us to be a little bit neater and more concise with our definitions, and it almost allows us to define functions which look like they're part of the language, similar to how a while would look or a for would look. You can then sort of add your own constructs which make it feel a little bit more like part of the language. And we've got that in the standard library with methods like for each or for each indexed. They are just functions, but by allowing us to pass in a lambda without having to wrap it in brackets, it can feel a little more intuitive. And speaking of the standard library, we've got a few more features in there as well for working with collections. So we've got sort of the standard sort of collections functions that you'd expect. So here in this example, we've got a list of names. We can then filter that with a predicate which checks that the length of the name is less than or equal to 4. We can map each one of those to make them uppercase, reverse the collection, and then join each item back to make a single string. So we can very nicely create a sort of declarative way of explaining what's going to happen to our list of names there. And that kind of leads nicely into the idea of being able to use Kotlin to teach algorithms. And one of the nice things here is that by trying to be as concise as we are and reducing the boilerplates, then you can actually fit a whole algorithm on a single slide, which I'm sure you can appreciate while trying to teach an algorithm is a very useful thing. You don't want anything to spill over or have too much text going on. The other nice thing is that implementations can quite often align very closely to what the pseudocode looks like inside your textbooks. So you end up with a structure which is very similar. And then there's additional syntax sugar which can help keep your implementations of these functions concise and easy to read. So there's other features we've got in the language like local functions, where you can define a single function inside the scope of another function so that it's private and kept only in that scope and can be reused but can encapsulate that code. We also have the idea of extension functions, which allow you to effectively add an additional function on an existing type. So you can then make it look like there are operations available on types which aren't there already, and again it helps it to make your code a little bit more readable. There's operator overloading as well, so you could use the plus symbol or the minus symbol or infix operators as well to be able to write more expressive code. So as an example of that, you can see here we've got sort of a simple tree traversal example. We've got a data class, which is a node. It's got a string value. It's got a left child and a right child. The left child and right child are nullable nodes. And so they have a default value as well with null. Unless you pass something in there, they will be null. And we have an in-order function. This function takes in another function as an argument. It takes in our operation. That operation is going to be a function which takes in a node, and its return type is unit. It doesn't actually have a return value. And so it's just going to call an operation on each node. The implementation of in-order is very simple. We use the conditional invoking operator again, the question mark dot operator, to call in-order recursively on the left child if it is not null. If it's null, that does nothing. Then we call the operation which you've passed in with the current node, and then we recursively call in order again with the right node if it exists. And you can see down the bottom then that we create a tree very simply just by passing in nodes into the constructors. We call tree.inOrder. We don't have to wrap it in braces, in parentheses, but we've got a functional literal there, which is just print line it.value. And so you can very quickly print out a simple algorithm there for walking down a tree. Another example I'm not going to dive into, but you can see how the structure of a depth-first search, as in pseudocode, maps very closely to the structure of it in actual code as well. So there's a similarity there, and it's very sort of easy to read and follow. So if you want to move to Kotlin, if you want to use Kotlin and start teaching it and using it and so on, what is it that, how does that work? And the good news is that your existing infrastructure keeps on working. So I've mentioned it's got 100% interoperability with Java, with the JVM, with existing tooling, existing libraries and everything. And that means that your existing unit tests keep on working. You know, you can mix Java and Kotlin within the same program. Your unit tests, which you've got written in Java, will carry on working. You're just calling now Kotlin code. Any abstractions and wrappers or libraries that you've got for the JVM, they also keep on working. You can just call them like you would any other functions or classes. And this is really crucial for things like your automated submissions, testings, and grading systems. Those just keep on working as well, perhaps with a minimal bit of migration to also allow compiling Kotlin code as well as Java code. And if we're talking a bit bigger than the language, then we also want to have a look at some of the tooling there. Obviously, you know, it's JetBrains, we build IDEs, so we have an IDE for Kotlin, and that is IntelliJ IDEA. IntelliJ IDEA is our IDE for Java and Kotlin. We've also got the same functionality inside Android Studio, which is maintained by Google, but it's built on top of the IntelliJ platform. IntelliJ IDEA is an award-winning IDE. It's got all of the things you'd expect from a rich IDE: navigation, indexing, quick fixes, hints, quick doc tooltips, which is really useful for helping your students. They can just hover over an additional function, and you get to see the documentation for what's going on there. Code inspections are a great way to help you learn, help you understand how to be a little bit more idiomatic with a language, and using very quick fixes, rewrite your code automatically to do that. Refactoring assistance as well. Please never use find and replace. Let's just use the tooling to do that for you. We can be more accurate and replace just the symbols that it needs to. And yes, rich navigation, so we can sort of do a code walk and very quickly understand what's going on with your code. One thing I'd like to point out as well about IntelliJ IDEA, if you haven't used it much recently, is that over the last few releases we've been working on a new UI. And so we've got a nice clean user interface now where we've been hiding some of the buttons which are not so regularly used. So you start with a much more reduced and minimal user interface there. You've kind of got a main toolbar which has effectively got your version control widget and then run and debug buttons as well. So it's very quick to get running, to get debugging, and there's less distracting functionality there. It's also worth pointing out that IntelliJ IDEA is open source. It's Apache license. That's the community edition of IntelliJ IDEA. That includes all of the features like version control and so on, but it also includes the Java and Kotlin tooling in there as well. And it's worth pointing out that this is quite an industry standard too, so again, you'd be setting up your students for success by helping them out with that one. The IDE can be very good with understanding your code too, so the idea of indexing everything allows us to give you very rich navigation. You can control, click, and navigate to the definitions of variables and functions, etc. So if you don't understand how a function works, you can just control, click, and navigate to it and read it. You can also show all the implementations of an interface or a subclass or a superclass, walk up and down the class hierarchy, find usages of functions as well, which is very useful to understand how your code is being used. And yeah, we can run and debug your code with a single click. Debugging is a great idea. You kind of interactively step through your code. You can see what's going on. You can follow the steps of your algorithms. You can see the state of the program as it is now. You can change those variables to see what happens if you're like, oh, I've got a bug there. Let's fix that interactively. That should have been a 3, not a 4. You can change that and see if it fixes things. And of course, you can just evaluate expressions as you go. Stepping outside the Kotlin-related stuff at the moment, then we've also got AI integration. We've got a great AI assistant, which has got brilliant context from the IDE itself. It can understand, obviously, what files you got open, what files have been changed in version control. It can even ask for more information from the IDE. We've got a whole load of indexes. The AI can actually use those indexes to find symbols, find files, find text, find usages, and show you more information there as well. This is actually a separate subscription to IDEA itself, but it's also worth knowing. There's lots of great integration with things like version control, so you can get somebody to explain your commit messages for when your colleagues haven't left any decent messages, or we can actually write it yourself, write it for you. We can also generate documentation for methods, because everybody loves writing API documentation. If you're using IDEA Ultimate, you've also got, or if you're using cli, for example, which is relevant to the ICPC community, we've also got full line completion, which is a local AI model. It's fine-tuned model downloaded to your device, and it runs locally. I just want to call out another feature of the IDE, which is useful if you are working with students, working in teams, and this is Code With Me, which is all about collaborative working. So we can do sort of pair programming sessions so the team can work together. It's not just a pair, it's anybody on the team that can all join in. And it's not just editing as well. You get to debug, test, run, and so on. We've got video chats in there too, so it's great for remote working. There is, have I shown? No, I haven't. We've got support for permissions there as well, so it can be a read-only view of the file, or it can be an editable one as well, so you can collaboratively work together, or you can guide students through a particular solution. Kotlin notebooks is another one, a great thing to call out here as well. So these are Jupyter notebooks using the Kotlin kernel rather than perhaps the more frequently used Python kernel. This is a great way to interactively work with your Kotlin code. So you can sort of get a feel of how to write Kotlin through that, but you can also use it to call your own libraries that you're working on there, so you can sort of interactively work with your application as you're going, and then visualize the data that comes out of it. So there's plotting tools there and everything. You can do prototyping here, data analysis, call web APIs. We've got a data frame library which works great with this as well. And we've also got a platform, a UI library for multi-platform as well. So if you are targeting multiple platforms, such as iOS, Android, desktop, and web, then you can use Compose multi-platform. It kind of takes Jetpack Compose and expands that to multiple platforms. And finally, one of the key things really is if you're using IntelliJ IDEA and you want to convert some of your existing examples or samples or exercises from Java to Kotlin, we've actually got a built-in conversion. So you can open a Java file, right-click on it, convert Java to Kotlin file, and we'll get you going to actually then have an exercise ready in Kotlin. So just to wrap up then, to kind of cover what I'm saying, Kotlin is a modern language. It's safe. We've got great null safety built in, and it's a very useful feature to try and to know what's going on with your code there. It's multi-paradigm with imperative, functional, object-oriented programming. We're aiming for conciseness and expressiveness, reduce the boilerplate, make it easy to read the actual logic behind your code. The standard library is brilliant, a lot of great features in there, especially with the more functional side of things, of higher order functions, of the collections API and so on. 100% interoperability with your existing Java code. It's academically recognized, it's being used in loads of great universities there, it's being used in lots of industry standard companies, and it's got great tooling as well. There's loads more things that I couldn't cover in this quick overview here. So obviously more information about the multi-platform sides of things. Coroutines and structured concurrency is a fantastic way to be doing sort of multi-threaded or just sort of concurrent programming. And Kotlin's got a very good story about this. It's very well thought through and it's very well worth looking at, and a great topic to be able to teach your students. The way that functions are specified with the sort of Lambda expressions as well allows you to introduce the idea of type-safe domain-specific languages. And this can be a very effective way of working with things. We've got a similar kind of thing as part of the libraries for working with generating HTML, for example. We can do that as part of a domain-specific language, and it looks, it's quite similar to the way that JSX files work, kinda-ish. But there's plenty more things in there which you can take a look at, you can teach to your students or not. It's basically what makes sense for your courses and for your students itself. So Kotlin basically gives you a good, solid foundation to learn as a programming language. If you're learning as a first language, it provides a great stepping stone to explore other programming languages. You can start small, expand out into other techniques. And once you've got that, then it's really quite straightforward to go to things like Swift, Python, JavaScript, Java, and C#. But it's also a great second language too. You can reuse your existing library knowledge, and you can learn the sort of more multi-paradigm kind of syntax with, by moving on from object-oriented to introducing functional concepts. And if you're going to be teaching, then, as pretty much what I've just said there, as a first programming language, you can gradually introduce the more programming topics there, so you can, without having to, explain all the boilerplate first. If you're using it as an algorithms-based language, then you can sort of focus more on the implementation without worrying too much about the verbosity. And as a general language, it gives you modern, generalizable programming habits that your students can use then as they move on to industry. So the key thing that we want to do is, what we're here for is we're going to give stuff away. There are free licenses. If you're a student, if you're an educator, we give you all of our IDEs for free. You can go to this link here, you can follow the QR code, fill in a form, and then we'll give you licenses for all the IDEs. If you're a school or university, we'll also give you the team tools as well, which would be issue tracking, continuous integration, code quality platforms, and so on. These can be installed, the IDEs as well here can be installed in classrooms rather than sort of being assigned to people. And so that brings me to the end. The last thing I want to point out is the kotlinlang.org/education link. So kind of everything I've mentioned here is mentioned there on that website. So kotlinlang.org is our main website for Kotlin, and /education is all the resources you would need to be bringing Kotlin to education. The email there is my colleague Xenia, who is in charge of Kotlin for education. If you have any questions, if you've got any follow-up or anything, please send us an email, please get in touch, come and see us at the booth, we'll still be here tomorrow. And yeah, so I think that brings me to an end. Thank you very much for your time, and I don't know if we have time for questions, but I'm more than happy to answer them.
Sure, so let's give Matt a round of applause. Yeah, and questions? Going once.
I think I covered everything then, that's good.
Yeah, comprehensive, I guess. All right, so let's give a round of applause again for Matt. Thank you. All right, so we have about 10 minutes, and actually there's a good reason why I'm going last, because I want to time it and make sure that we finish on time, right? So let's try to make it fast. I'll try my best, so bear with me. First of all, I want to say this ICPC curriculum committee has started maybe a couple years ago when I joined, but I know that there has been effort by Frederick again, and also Etienne, and I think Maddox there. Yeah, so if you can stand up, I guess, so they can get recognized, that'll be great. Yeah, so let's give all of them a round of applause, yeah? All right, so what is this, right? So the goal, vision, curriculum, the core team, call for participation, this is a key, and the future work, right? So let's go. Goals here are threefold. We want to serve the community, we want to help the coaches who'd like to use this, and really want to bring the participation of the people with deep insights and experiences, right? So that I'm pretty sure is actually all of you and more. And that's why I want to really ask you that, if you have some time, that you can actually reach out to me for, I guess, getting involved, right? So the vision is to provide the complete materials, lecture slides, homeworks, worked problems, and exercises that really can help each and every student who is trying to learn from this. There are 5 courses that we are under development. A regular course length is 1 semester, which means 15 weeks, 1 hour per week. It can be 2 hours, right, with 1 practicum session per week. And that being said, the curriculum consists of, like maybe a little bit rudimentary topic for course 1. Then we do a little bit more complicated things for course 2. And as you go to the future iterations, you'll see that the topics get more and more esoteric. So, for example, heliotropic or convex relaxation in course 4 is that something that comes up in the ICPC maybe once or twice, but that's it, right? So as we go to the next future topics, it's not even clear whether we actually need this, right? So course 1 and 2, those are very important, of course. And course 3 and 4, get to the 4, maybe not so much. And in progress, we have divide and conquer, Kuhn's algorithm, and various different probabilistic things, parametric search, and so on. So a complete list actually can be found here, and this actually, there's a link to this in the CLI website. So if you follow through the link that is given to you in the pocket guide, then you can actually find this. And the core team, as I mentioned, is myself, and then Etienne, who actually stood up. And regular members are Arup, Ben, Glenn, Samantha, Tolga. When I say regulars, I really mean that they come to the meetings all the time. They really make sure we get things done. And there are a lot of other contributors to this that I actually shared in the, let's say, in the website, but I wasn't able to share because space is limited. Now, the future work, we want to refine the slide decks, select more problems for each topic, refine solutions for each problem, publish related works through our journal, and write a textbook series. I'm pretty sure it was a repeated topic that a lot of you actually talked about. And so we don't have to repeat the same thing. But what I really want to do is bring the community together. So here is really one punchline here. We need your help. And when I say help, any of these things that we mentioned, if you can help, please reach out to me. And if you're interested, reach out to my email. That's 5 minutes, I think. And thank you. So any questions, I guess, from the audience? OK. That was short. And maybe round of applause for myself, yeah? And there's a good reason why I left 5 minutes at the end, and here goes. Eric actually was not able to join us, unfortunately, due to personal reasons. But I also want to make sure that Eric's talk is covered here, right? He's actually creating a great effort called Journal of Competitive Learning. There is a website there. They can actually look. Editorial team is Eric, Thomas, Bill Booth, myself, and Bill Potcher. So if you're interested in submitting to this journal, please reach out to me. And CLI Symposium, more information can be found here, as I mentioned. And finally, a survey. So what I really want to know from each and every one of you here, the fact that you're here right now is a testament that you really care about this symposium to one way or another, right? Otherwise, you'll not be spending just around the dinner time to be here. So that being said, I really want to get an input from you, each and every one of you, so that we can actually make this better for next iteration and onwards. And I also want to mention that maybe I don't have to be always the person who gives talks about the curriculum committee, because I think we can rotate. I'm happy to do so. For example, Etienne can give a presentation next time, or maybe one of the regular members. And that being said, yeah, I guess we are on time after all. So thanks everyone. And if you want to actually take a picture, because the group is smaller today, let's do that and then finish it. So with that being said, let's end. So thanks everyone. If you want to come to the front for the picture time, that'll be amazing. Yeah, maybe especially the speakers and the rest of you. Yeah. All right, thanks everyone.